In the final lesson of the GearVR framework tutorial, we're going to learn to work with assets. These are things that are not created programmatically inside GearVRF. Instead, they're created by artists. Usually the assets are produced with digital content creation tools like Max or Photoshop or Maya, and most of the time they're binary data like meshes and textures. Sometimes an asset can describe an entire scene, including animations and interactions, like the X3D file format can do this. So examples of assets might be a cube map texture, or any texture for that matter, a simple 3D model, a scanned character, or even a complicated scene. To load assets in GearVRF, we call the GearVR asset loader. This loads 3D models and their associated textures. There's the load model function. There's a couple of different variations on it. And this function will load a single 3D model and return the scene graph that it produces. The textures used by the model are loaded asynchronously, and you can observe the asset load events if you want, although we won't talk about that in this tutorial. Right now we support a number of different 3D file formats, and we're adding more all the time. The assets that are imported by the asset loader all use the GearVR Fong shader template. And this is because this shader is the only one that will support multiple lights. And it also supports a lot of different texture mapping options. To load textures, you use GearVR Context. And textures can be loaded either asynchronously, or you can have your application just wait until the texture is loaded. We recommend asynchronous loading because then it lets your thread do something else while it's waiting for the texture to load. We support a number of different file formats, including cube maps and compressed textures, but it's notable that we do not support TIFF or Targa. So here's an example of loading a 3D model. Now, this model is specifically going to be the one that we're going to load in the tutorial. And it is a picture frame that we're going to use to make the scoreboard look prettier in the game. The original model is large, much too large, and it's oriented in the wrong perspective. So what we're going to do is load the model and then get the bounding volume and try and scale the model down to fit. And then we're going to rotate it around the Y and the Z-axis so that it will face us and it'll have this aspect ratio. And that's what this code does. Let's see where this section of code goes. If we want to improve the scoreboard, we would put it in the make scoreboard routine that we have already in the application. This ... here is the code that I just showed previously that actually loads the frame asset that we're going to put around the scoreboard. But in addition to putting the frame around the scoreboard, we're actually going to center the score, and we want to make the background transparent. And in order to make the background transparent, we have to enable alpha blending. We have to set the rendering order to be either overlay or transparent. The rendering order controls what order the objects are drawn in. And then we want to disable the depth test so that no matter what, it's always going to be on top. And once we do this, we add a collider. The mesh collider will allow us to be able to pick the scoreboard in the game. And what's going to happen is if you pick the scoreboard at the end, it'll start the game over. Here we are in Android Studio, and we're going to replace the old make scoreboard routine with this new one that will load assets. Now the new one actually takes an extra parameter, and that is what object you want to attach the scoreboard to. So we'll go back into the code where we add the scoreboard, and we'll add that parameter, and that parameter would be the head tracker. And now we don't have to attach it because we're attaching it inside the make scoreboard routine. So far, we haven't really done anything with the scoreboard, so let's look and see how we would put it into our game. If you remember from the last tutorials, the games start enables the scoreboard and positions it in the upper left corner. And now that we have a collider, we're also going to disable picking so that if you're playing the game, you can't pick the scoreboard. The timer starts and it will run for 1 minute, and then it'll call the game over routine here, and we do the opposite of what we just did in game start. We disable particles so that nothing is being generated. Then we position the scoreboard in the center, and we enable the collider so that it can be picked, and then we make the text just a little bit smaller so that the tap to play again will fit. Now let's replace game start and game over with our new versions that we've just developed. We can also get rid of the logic that starts the timer because now we're going to do that inside game start. So we can just call game start at the very end here. And finally, we're going to put something in to test whether or not we've picked. So we don't really need this game over flag because we want to see if we've picked the scoreboard or not. And when we add that, that's an easier way to be able to tell if the game is over. So let's put that code in there. And now we can actually try to see what our scoreboard looks like by building and trying on the phone. Before we try it on the phone, we have to remember that you need to put mirror.3ds, xx.jpg, and this burlwood.bmp in your assets folder, or the frame won't show up. So let's build it and look and see what does the application look like when we run it. Here you see our scoreboard. It still scores, but now it's this pretty little frame around it. Now I'm going to play the game for a while so you can see if our game over logic works. And here you see we have 355 points. So maybe I'm getting better, not clear. We hope that this tutorial has been helpful in learning how to use the GearVR framework. I had a good time preparing it, and we hope that you'll visit www.gearvrf.org to find out more about GearVRF.